All right, guys, so we are in part 2 of Unit 2 now, where we're going to start talking about triangles. So today's our first lesson, 11-1, which is going to be congruent triangles. We're going to talk about congruent parts of triangles, or corresponding parts. We're also going to talk about how to find unknown angle measures and side lengths of congruent triangles. So open up to page 143, and we're going to go ahead and get started here. So we have this guy, Greg. Greg works for Green Construction Company. The company is building a new recreational hall, and the roof of the hall will be supported by triangular trusses, like the picture shown here. Each of the trusses contains pairs of congruent triangles. So remember, congruent triangles are triangles that have the same size and shape. Okay. So Greg's first job will be to determine the side lengths and angle measures in the triangles that make up the trusses. So Greg asks himself, if I know that the two triangles are congruent and I know the side lengths and angle measures in one triangle, do I have to measure all the sides and angles for the other? So he's going to begin by examining these two triangles, triangle ABC and triangle DEF. Okay. So because the two triangles are congruent, can one triangle be mapped onto the other? So that kind of goes with what we just did in the previous part of Unit 2, where we did transformations. Is there a way to transform that pre-image ABC onto an image DEF? So let's look at that. So if we want those to stay congruent, remember, congruent figures need to be transformed using a rigid motion. So yes, we can do this, but it needs to be a rigid motion so that preserves the size and the shape of the pre-image in the image. So if I'm looking at triangle ABC and how it maps to DEF, to me this kind of looks like a reflection, right? A flip. So like angle A would map to angle D, angle B would map to angle E, and angle C would kind of map to angle F if it's reflected over that dashed line. So suppose you use a sequence of rigid motions like the reflection I just kind of talked about. Find the image of each of the following under this sequence of transformations. So if we're calling this a reflection. If we reflect that, AB is going to reflect to which line in the other triangle DEF. So take a second and think about that. Well, it kind of looks like AB, if this is flipped over, it would go to DE, right? So those parts would kind of line up together. So fill in the rest of this. Where would BC and AC go? And then what angles go with angle A, angle B, and angle C? So take a second and fill in the rest of this and see what you get. Okay, so if we did it, we should have had, that AB is going to map onto, I already did this one, DF, or DE, sorry. BC is going to map to EF, and AC is going to map to DF. And then I kind of already did those angles there when I kind of made those marks. Angle A is going to go with angle D. Angle B and angle E go together. And angle C and angle F go together. Okay. So what is this relationship then? If they are mapping onto each other and it's a rigid motion, then I would know that those are going to be congruent to each other. So AB, for example, is congruent to DE. Same thing with the angles. If I have angle B, I know that's going to be congruent then to angle E. Okay, because again, it was a rigid motion transformation. So this is what we would call corresponding parts of the triangle. So corresponding parts results from a one-to-one matching of sides and angles from one figure to another. Okay, so in congruent triangles, corresponding pairs of sides are congruent and corresponding pairs of angles are congruent. So in a triangle, you have 3 pairs of sides that match up and 3 pairs of congruent angles. If we had a square, we would have 4, or I guess a rectangle, we would have 4 congruent sides and 4 congruent angles, okay, pairs. So the big key of today's notes is this last paragraph here on this page, okay, which talks about the congruent statements. So when you write a congruent statement like triangle ABC is congruent to DEF, so maybe I'll make a couple triangles here. So there's a triangle, and then I'm going to clone him so they're the exact same triangle. Okay, the order that you write this congruent statement in really matters here. So if I call this triangle ABC, and they tell you that these triangles are congruent, then I need to label D, E, F in the exact same order. So D, E, F. Okay, you write it so that the vertices of the corresponding parts are in the same order. And you do this so we can conclude the following statement. So if they are congruent triangles, and we write it using that congruent statement, everything's going to correspond with each other. So for example, angle A goes with angle D. Angle B goes with angle E. Angle C goes with angle F. So if I look at it here, A is the first letter, D is the first letter. C is the last letter, F is the last letter. So you can also look at the congruent statement and know what angles are supposed to match up. Similar with the side lengths, if I match these up and I write it the exact same way, then you know right away that AB corresponds with DE. Same thing if I have AC has to correspond with DF. And lastly, on the bottom there, BC would have to line up with EF. So the congruent statement tells you the order and what corresponds with what in the triangle. Okay, what three angles correspond with each other and what three sides correspond with each other. So let's go ahead and do some examples. So example A is already done for us in the book, so I'm just going to jump to the try these A, where we have this triangle RST, and they say that is congruent to XYZ. So again, what that tells me is that order is going to tell me what goes together. So angle R has to match up with angle X. Angle S has to match up with angle Y. And lastly, angle T would have to match up with angle Z. And those lengths, if I kind of color code this a little bit, we have RS, that has to be the same as XY. So RS, XY. Okay. Let's see, ST goes with YZ. ST, YZ. And lastly, if we have RT, that has to line up with XZ. So if you do that and kind of color code it, you should see what goes together really quick, okay? So what they want us to do is to look at the measure of these and find the measure if it's possible. So let's look at X. Okay, they want to know what's the measure of angle S. So can we figure that out? So angle X has to line up with angle R. So since I don't actually know what angle R is, this one's actually not possible. So with the information they gave us, I can't actually find the measure of angle X or R. Okay, so let's go on then to B. B wants us to find the length of YZ. So I have this nice and color-coded, so that should help us. So YZ is my blue line. So does that match up with something on the other triangle, which was ST? It does. So since ST is 15 centimeters, and these are congruent, then YZ is the same length, 15 centimeters. Okay, can we find the measure of angle T? Well, angle T was my third angle, so if I match that, it goes with angle Z, which I kind of wrote over it, but they told us was 47 degrees. So those angles have the exact same measure since these are congruent triangles. All right, last one, XZ. XZ is my purple line, which is RT, but since we don't know the length of RT, I can't find the length of XZ actually either. Okay, so kind of follow-up question to this. If we have two triangles, JKL and MNP, and they are equilateral triangles, I'm doing my best here to draw an equilateral triangle. So remember, equilateral triangle means all the sides are the same and all the angles are the same. So they're saying in which the angle is each 60 degrees. So let me draw that out. So here's an equilateral triangle where everything is 60 degrees. Can we say that those two triangles are congruent? So this is JKL. And they're both equilateral triangles. Does that prove that M and P is the same, is the congruent to JKL? Well, actually, the answer to this is no. So I'm going to kind of prove it here in a second. So the answer is no. Not all equilateral triangles are going to have the same size. So even though they have the same measure and angles, all the angles are congruent. What if we had an equilateral triangle like this? Where I make it a little bigger here. Now, instead of JKL, this could be our MNP. My pen. MNP. Okay, so even though they are both equilateral triangles, MNP is bigger. So just because you know that the angles are the same doesn't mean you know that the sides are all the same. In order to be congruent, they have to have congruent angles and congruent side lengths. Okay, so just be aware of that. Doesn't always mean that they're congruent, unless we are told a congruent statement. All right, you guys are going to try some problems on this last page here. We're not going to do all of them, but I want you to look at number 7. So in the check your understanding, number 7, you have two triangles. You have PQR, and you have triangle GHJ. So if it helps you, you can always kind of make some triangles and label them. So there's some congruent triangles there. You can label those out and kind of match up what goes together, but I'm going to have you guys try this one. So match up what corresponding parts go with each other. Again, draw some triangles out if it helps you and label them. Okay, so if I'm labeling these triangles, I'm making sure to label them in the exact same order. And then I can clearly kind of see which one should pair up with each other. So QR would pair up with HJ. And then GJ would pair up with PR. And then my angles R and J go together, so G and P go together. Okay. So again, make a picture if it helps you. Color code it, draw on it, do whatever you got to do to kind of help yourself match up what goes together. And remember the order. So QR, you can even look at the congruent statement, QR, HJ. You can kind of line up what kind of is in the same spot there also. Okay, we're just going to finish up then with this questions 8, 9, and 10. So they're telling you the triangle ABC is congruent to DFE. So that's a fact. So we know that all their corresponding sides and their corresponding angles are congruent. So what they're going to have you do in number 8 is find the length of AB. And number 9, find the measure of all the angles, if it's possible, in the triangle DEF. And then find the perimeter of DEF is number 10. So go ahead and try 8, 9, and 10 really quick. And then that's the end of our lesson. Okay, if you got everything correct, AB has to line up according to our congruent statement. AB would have to go with DF. AB and DF have to go together. So since DF is 18, AB is 18. Now, for the measure of all the angles, we can't actually find all of them. The only one that we can actually find is angle D, because angle D goes with angle A. Again, D and A, they're in the same placement in the congruent statement, so those go together. So you can figure out what angle D is, but that's it. And then the last one, can we find the perimeter of DEF? So the answer is 73. So the way you can find that is because AC is going to be congruent to ED, because they're corresponding parts. So that makes this side 33. So if we add up all sides, you should get your answer there of 73 inches. Okay, so that's all for our first lesson on congruent triangles. Again, the big part of this whole lesson is doing that one paragraph. Okay, on the bottom of page 144, where it talks about the congruent statement. Okay, again, the order matters that you write that congruent statement in, because that will tell you what corresponds with each other.